This video discusses two variable inequalities. Okay, you've been given a problem similar to number 68 on page 539 in your textbook. Okay, well, this video, for the purposes of demonstrating the math needed for this assignment, that's what this video is going to go over. All right. Okay, so the problem that we're going to be working through in this video is a shipping container can carry a maximum of 125 sofas and no recliners, or a maximum of 275 recliners and no sofas. You're to write an equation to fit the line. All right, you want to pretend that the triangle region is shaded in and change the equation to an inequality describing this region. Okay, so let's look at this here. All right, so we know that the shipping container can carry a maximum of 125 sofas and no recliners. Okay, so we have our maximums. All right. So here on our graph here, you can see that I've graphed out the point 125, 0. Okay, so this is on our x-axis here. Okay, so this is going to represent our sofas. So the x-axis is going to represent the sofas, and then the y-axis is going to represent the recliners. Okay, so if our maximum is 125 sofas and no recliners, that's this point right here. And then for our recliners, our maximum is 275 recliners and no sofas. So I've marked here the point that represents that maximum for recliners. Okay, so 275 recliners, so it's 0 sofas and then 275 recliners. That's going to be our y coordinate. I have drawn here in orange the line that represents the maximum. Okay, so anything including this line in this region here that I've shaded in orange is will fit in this shipping container. Okay, so now that includes on the line, so that's why the line is solid and not dashed. Okay, so in order to write an equation to fit this line, we have to know what the slope is. And since we've been given 2 points, we can use these coordinates to find the slope. All right, so the slope formula, or the coordinate formula, will help us find the slope with using 2 points. Okay, so the slope formula is m equals y2 minus y1, okay, over x2 minus x1. Now, for these coordinates, it doesn't matter which order you put them in as long as you're consistent. So we could have said this. We could have said m equals y1 minus y2 over x1, see how I'm being consistent, okay, our position, minus x2. Either way is correct as long as you're consistent in placing your coordinates here. Okay, so remember our coordinates. Okay, so over here we have x1 is 0, right? So we could do x1 is 0, and then y1 is 275, and then down here you have 125. This is our x2, okay, and then 0, which is y2. Okay, so then you basically just plug in the values over here. So y1 is 275, and y2 is 0. Place that over x1, which is 0, and x2, which is 125. All right, so 275 minus 0 is 275. Place that over 0 minus 125 is negative 125. Okay, and then we can reduce this. 25 goes into each of these numbers. Okay, so this becomes negative 11/5. All right, so our slope is negative 11/5. All right, so because we know a point and a slope, we can then use the point-slope form to write the linear equation. y1 minus y2 equals m x1 minus x2. Okay, it doesn't matter which point you use, so we're just going to use 275 and 0. Okay, we're going to use our maximum recliners. All right, so let's go ahead and plug those in. So we're going to do y1 minus 275 equals our slope that we just figured out, which is 11/5, and then our next point, which is x minus 0. Okay. So now at this point, we're going to use the distributive property, and then we're going to add the 275 to both sides. Our goal at this point is to get this equation in slope-intercept form, okay, which is y equals mx plus b. Okay, so let's go ahead and do that. So we're going to first distribute our negative 11/5, okay, and this is going to be 0, so we don't have to write anything there. All right, so now we're going to add 275 to both sides to get rid of the 275 over here, because remember, right, we're trying to isolate y, right? Get it on the left-hand side. To isolate y, we're going to get y equals, and we're going to add 275 to both sides to get rid of the 275 from over here. Okay, so now our formula is in slope-intercept form. And then at this point, we want to change this so that it is in standard form, okay? And then once it's in standard form, then we can change it to an inequality so that we can describe the region here, okay? So standard form is ax plus by equals c, okay? So remember back, that's what standard form is. All right. Okay, so now that we have it in slope-intercept form, at this point our goal is to rewrite this in standard form so that we can change it to an inequality to describe the region. All right. Well, when it's in standard form, we can't have any fractions. So let's go ahead and take care of that first, and we'll get rid of our fractions. Okay. So let's go ahead and to get rid of the fraction, we have to multiply each of these terms by 5. All right. So let's go ahead and do that. So to multiply the left side by 5, we end up with 5y, all right? And then here when we multiply it by 5, we're going to be left with 11 minus 11x, and then plus, and then 275 times 5, which is 1375. All right, and so now what we need to do is we need to get the minus 11x on the left-hand side. So to do that, we have to add 11x, okay? So we're going to do 11x, and then we're going to leave the 5y, and then we're going to add 11x here, and that's going to go away, and then we're left with 1375 over here. All right, so now it's in standard form. So now we want to change this linear equation to an inequality so that we can describe our region here, okay? Well, everything, it needs to be less than or equal to, okay, everything on this line here, okay? So to do that, we would change our equal sign, all right, to less than or equal to 1375, so that it describes this region, the shaded region here, the orange shaded region. Okay, so now the graph has a solid line, all right, rather than a dotted line, because that indicates that the points on the line itself will be part of the solution set. Okay, so this will be true anytime the inequality symbol has that equal bar in it. Okay, so we've completed the equation here, actually the inequality. All right, we've changed our equation to an inequality. Okay, so now we've been asked to use this inequality that we just created, all right, the 11x plus 5y, which is less than or equal to 1375. So we're going to use that inequality to evaluate a couple of other scenarios, all right. The first scenario is, will the shipping container hold 80 sofas and 200 recliners? Or in other words, is the point 80, 200 in the solution region, okay? Where does that fall on our graph? All right, so this is called a test point. Okay, so it's going to be used to make sure the shading will fall on the correct side of the line. All right, so let's go ahead and do that. So to determine the actual solution, the ordered pair, it must be substituted into the inequality that we just created. All right, so if a true statement is made, then the combination of sofas and recliners will work. All right, they will fit in this shipping container. So let's go ahead and do that. So I'm going to erase what I've done for the prior problem, and so we can start this new one. Okay, so we want to know if the point 80, 200 will fit in this region here, okay? Where is it gonna fall? Inside or outside of this region? Okay, or even on the line, okay? So if it falls on the line or inside this region, then yes, it will fit in our shipping container, okay? But if it falls outside of the region or not on the line, then it will not fit in the shipping container. Let's go ahead and plug that into our inequality here. Let me rewrite the inequality so we have that available. All right, so at this point, all we need to do is plug in our point into the x and y values, okay? So what we're trying to evaluate is the point 80, 200. All right, so let's go ahead and do that. All right, so 11 times 80 is 880, plus 5 times 200 is 1,000, less than or equal to 1375. 880 plus 1,000 is 1880, less than 1375. Okay, so as we can see, 1880 is not less than or equal to 1375, so this is false. Okay, so that means this point falls outside of our region here. So the container will not hold this particular amount given. All right, so that is that one. And so let's go ahead now and solve our second question here. Will the shipping container hold 68 sofas and 125 recliners? So let's go ahead and work through that one. 68 and 125. So let's go ahead and plug that into our inequality. Eleven times 68 is 748, plus 5 times 125 is 625. 748 plus 625 is 1373. And as we can see, 1373 is less than or equal to 1375. So this is a true statement. So that means that this particular shipment of 68 sofas and 125 recliners would definitely fit into this shipping container. Okay, our next problem requires a minimum or a maximum range, okay? So you'll have to check your problem and see which one yours requires. This particular one wants to know what the maximum number is, so that's what we're going to be using. All right, so the Burbank Buy More store is going to make an order which will include at most 75 sofas. So what is the maximum number of recliners that could also be delivered in the same shipping container? All right. And then we're going to need to describe their restrictions. This would add to our existing graph, all right? So let's go ahead and plug in the maximum number of sofas into our linear inequality and then solve for y, all right? So let's go ahead and do that. All right, 11 times 75 is 825. And so then we're going to, remember we're trying to isolate y, so right now 825 is being added to it. So to undo that, we're going to subtract it from both sides, all right? So this side we're going to be left with 5y, and then we're going to subtract 825 from 1375, which is 550. And then y is still not by itself, it's being multiplied by 5. So we're going to divide by 5 to undo that multiplication. All right, and so what you do to one side, you have to do to the other. And 550 divided by 5 is 110. All right, so the maximum number of recliners that could also be shipped in the same container is 110. All right, so on this, then the graph would now have a horizontal line at y. All right, so y equals 110. All right, so the maximum number of recliners that could also be shipped in the same container is 110. So the graph, it would now have a horizontal line at y equals 110 and a vertical line at x equals 75. So I've erased our prior graph here and just put the basic inequality here. All right, so we're going to show what that would look like on the graph here. All right, so again, so our vertical line is going to be at 75. So we count over to 75, 20, 30, 40, 50, 60, 75. So like right in here. So we're going to draw our vertical line here. Okay, so it's going to go there, and then a horizontal line at 110. Let's see here. So 10, 20. All right, so that's going to be right in here. All right, so so this is what our what the graph is going to look like here, okay? And it's going to cover this shaded area in here. All right, so all in here will be included in this particular problem. All right, so the only possible shipments then would fall inside of this rectangle. All right. Well, the next day, Burbank Moore decides that they'll have a recliner sale, so they change their order to include at least 170 recliners. All right. So and they want to know what the maximum number of sofas which could also be delivered in the same truck. All right. So again, we're going to do a similar thing, but this now we're dealing with recliners. All right. So we're going to plug that coordinate in there and then solve. So let me go ahead and redo this problem. All right, so we're going to substitute the given values. Okay, remember we're dealing with recliners, so we're dealing with the y coordinate. Okay, so let's go ahead and plug that value in. So we have 11x plus 5 times 170 is 850, less than or equal to 1375. So we're going to, again, we're solving for x, so we right now 850 is being added to it, so to undo that, we have to subtract 850 from both sides to keep our equation in balance. Okay, so the left side, the 850 goes away over there, and then 1375 minus 850 is 525. So the x is still not all by itself, okay? So it's being multiplied by 11. So to undo multiplication, we're going to divide by 11, all right? So it's going to cancel out on the left side. And then we're going to be left with 47 over here because 525 divided by 11 is 47, all right? Well, we rounded that because partial pieces of furniture, it's not really realistic. So in this case, we're going to round down, okay, because 525 divided by 11, you're looking at 47.72. And so since you can't, again, have a partial piece of furniture, round down, all right, to a complete sofa. So 47 is what we're going to use. All right, if 170 recliners are shipped, then the maximum possible sofas in the same shipping container would be 47. All right, so let's go ahead and graph that. So our graph, it would now need to have a horizontal line at y is 170. All right, and then we're going to enclose that triangular shape above that line. All right, so that would be shaded above it. All right, so let's go ahead and do that. So 170 on the y axis, so it's right here. So this is where we're going to draw our line. All right, and so again, the graph, the triangular shape above that line is what we're going to shade. So all in there here. That concludes all of the problems that we have for this particular assignment, and so that will conclude this video.